expert, Dr. Allison Burbank, will help us better understand those challenges and the effects they will have on individuals living with asthma. Dr. Burbank is an associate professor of pediatrics in the Division of Allergy and Immunology at the University of North Carolina at Chapel Hill. Her research efforts include identifying the environmental and social determinants of poorly controlled asthma in children and developing interventions to promote asthma-related health equity in high-risk populations, particularly in rural communities. In addition, Dr. Burbank has an interest in digital health to improve asthma control in children and adolescents. Welcome, Dr. Burbank.
Thank you so much. I'm so happy to be here. And so this talk is going to be focused on climate change and how it's relevant to asthma and how we think that climate change may impact asthma going into the future. So to start, I have no relevant disclosures. So a lot of times we use the term global warming synonymously with climate change, but really a more appropriate definition is the long-term shift in temperature and weather patterns. There are both natural and man-made causes of these changes in the patterns, although for the most part, what we've seen in the last 100 years, the increases in temperature and warming really cannot be explained by natural causes. The Earth has seen a 1.1 degrees Celsius increase in temperature since the late 1800s. And the decade of 2011 to 2020 was the warmest decade on record. This is a figure showing surface temperature changes from the period of, I believe, from the 80s to current relative to 1900 to 1960s. And you can see the red shaded areas indicate positive change in temperature, so increasing temperature, and basically the whole map is red. So we're definitely seeing increased surface temperatures. And we're on track to see a rise in global surface temperatures of 2.8 degrees Celsius by the end of this century. This is a graph of reconstructed temperatures over the last 2,000 years, and you can see there are some ups and downs. For instance, there was a period of warming during the medieval period, followed by a subsequent drop in global temperatures, sometimes referred to as the Little Ice Age. But then to the right, you can see this very steep rise in temperature over the last 100 to 150 years. And this is primarily due to human activities, particularly the generation of greenhouse gases. But we know that climate change isn't just about warming temperatures, it's also about more intense storms, hurricanes, flooding events, wildfires, and rising sea levels. So the picture to the left, it was taken some of the flooding damage that occurred in the western part of North Carolina, which is my home state, as a result of Hurricane Helene. So that was just very recently. And then last year, we saw the absolute devastation with the Lahaina wildfires on Maui. So what are greenhouse gases? So greenhouse gases are substances that trap heat in the atmosphere. And the biggest ones that we think about, obviously, is carbon dioxide, but also methane, nitrous oxide, and F gases are also very good at trapping heat in the atmosphere. So normally, under normal conditions, we do see a greenhouse effect where solar radiation comes into our atmosphere. It's then reflected off the surface of the Earth, and most of that heat escapes back out into space. But some of it does get trapped in our atmosphere, and that's what makes our planet habitable. However, on the right-hand side, you can see this sort of enhanced greenhouse effect, and this is caused by high concentrations of CO2 and other greenhouse gases in the atmosphere. So we're still getting that solar radiation coming in, it's bouncing off the surface of the Earth, but more of it's getting trapped by those gases in the atmosphere. And the major contributors to greenhouse gases are the burning of fossil fuels, also deforestation and agriculture. So what does climate change have to do with asthma? So in the rest of this talk, I'm going to talk about how 3 of the major determinants of asthma morbidity are impacted by climate change. So we're going to talk about allergens, air pollution, and infections, specifically respiratory viruses. So start with allergen. So as Dr. Marshall was talking about, we know now that asthma comes in many different flavors. And so this figure on the left-hand side is showing many of the described types of asthma. But as you can see in green here, allergic asthma is the most common phenotype of asthma, especially in childhood onset asthma. And so there's a number of allergens that have been shown to be relevant to asthma, particularly house dust mites, cockroach, mouse, molds like Alternaria, which is an outdoor mold, and then pollens, so tree pollens, grass pollens, and ragweed pollens. So as we're seeing these changes both in global temperature, we're also seeing changes in total annual precipitation. And you can see in this graph on the left that for the majority of the United States, we are seeing an increase in total annual precipitation. And that's also going to be reflected in changes in humidity. And so because we're talking about outdoor pollens and plants, we know that temperature, precipitation, humidity, those are all going to be very important determinants of how well these pollen-producing plants are going to grow. And so what we've seen over the last couple of decades is that pollen seasons are starting earlier and they're ending later. So we're having longer pollen seasons. We're also seeing an increase in the amount of pollen that's emitted during the season and increases in peak pollen levels during the season. And so this figure to the right is showing changes in ragweed pollen season from the period of 1995 to 2015, so a relatively short period of time. But they've documented increases in the duration of ragweed pollen season by up to 25 days longer in some of these sites. So this is definitely something that we're seeing. Now, this increase in temperature, humidity, and precipitation not only alters the growth of allergenic plants, but also their distribution. And so we're seeing these plants growing and thriving in places where normally that wouldn't be suitable for them to grow. Interestingly, higher carbon dioxide concentrations also seem to cause higher pollen production and production of pollen that is more potent in its ability to elicit an allergic response. So, so in this bar graph that's up now, this one group decided to study ragweed plants grown under different conditions. So one group, they grew under CO2 conditions that were similar to pre-industrial levels. The middle group was grown under conditions similar to what we're seeing now in terms of the carbon dioxide concentrations in the atmosphere. And then the last group was grown under projected CO2 conditions. And you can see that as carbon dioxide concentration goes up, the production of the primary allergen, AMB1 in ragweed, is going up and up and up. So as I was just saying, climate change does seem to be modifying the geographic distribution of allergenic plants. So this is a graph of Europe, and what the colors represent are the suitability of the environment for the growth of ragweed. So dark blue indicates very unsuitable conditions, and the dark orange indicates very suitable. So the figure on the left is showing sort of the current suitability for the growth of ragweed, and the figure on the right is showing projections for the period of 2050 to 2070. And so you can see the increase in the dark orange is indicating that these conditions are better for promoting growth of ragweed. So you may have areas that previously didn't get exposed to ragweed pollen that are now experiencing it. Okay, and so increased temperature, increased moisture, these are all obviously relevant for things that grow outside, like pollen-producing plants. But they also have implications for indoor allergens as well. So we know that house dust mite is very dependent on high humidity. And so when you're seeing humidity going up, you're expanding the areas that are going to be suitable for the growth and survival of house dust mites. And similarly with molds. So, you've got increased precipitation events, increased flooding events, and then once homes are damaged by floodwaters, it's very difficult to then get the water out and remediate the moisture that's come in. And so you can see in this figure on the right, there's this line where you can see that's where the water infiltrated into the house. And below that line, there's a large amount of mold growing there. So we do expect to see some changes to indoor allergens as well because of climate change. And interestingly, they've also found that carbon dioxide might also promote the growth of certain molds. So this is Alternaria, which is primarily an outdoor allergen, but it's very tightly linked with asthma exacerbation. And so the CO2 itself might be driving some increased exposure to mold. So what does this mean for asthma? So we know that there are positive associations between pollen counts and emergency room visits and hospitalizations for asthma. The strongest data for this relationship being for tree and ragweed pollen in the US. But there's also concern, could there be an increased risk of allergen sensitization with these high levels? And we don't know that yet, but I think that is something that we're going to be looking at in the future. And similarly for the indoor allergens, we know that house dust mite exposure and fungal exposures are both tightly linked with asthma exacerbations. So all of this is adding up to the potential for a lot more asthma morbidity as a result of changes in allergens. And then finally, there's this concept of thunderstorm asthma, where you see conditions with high pollen levels and thunderstorms, followed by an epidemic of emergency visits and hospitalizations for asthma. And the thought, although it's not completely understood how it works, but it's thought that during the storm, these pollens are fragmented into smaller pieces that are then able to penetrate better into the lungs, and that triggers a lot of asthma flares. Okay, so now I want to talk a little bit about climate change and how it's going to change air pollution and vice versa. So we know that the two are very tightly linked together. When we burn fossil fuels, we produce carbon dioxide that's released into the atmosphere and results in warming. But it's not the only thing that's produced when you burn fossil fuels. You're also producing other types of toxic emissions like particulate matter, nitrogen oxides, and volatile organic compounds. And when you put the two together, these toxic emissions plus warmer temperatures, you're accelerating the formation of ground level ozone, which has also been shown to have significant effects on asthma. So you really get into this vicious cycle. So you've got increased emissions of all these things because we're burning fossil fuels for energy. That's leading to warmer temperatures. So then we need to use more fossil fuels to cool our homes and buildings, and the cycle repeats. So PM 2.5 is particularly strongly linked with asthma. So we know that it affects both asthma outcomes in established asthma and also increases the risk of developing asthma with early life exposure. And climate change is projected to change the exposure to PM 2.5 throughout the world because it's affected by weather, precipitation, et cetera. So in this figure, it's showing changes in the projected level of PM 2.5 exposure across the world. And the red areas are showing areas where PM exposure is predicted to go up, and blue is where it's predicted to go down. Another component, or another source of particulate matter in the environment is wildfire. So we definitely have seen a spike in the frequency and severity of wildfires over the last couple of decades. In fact, just between the period of 2020 to 2023, the annual average area burned was 3 times higher than in the previous decade. So we've got another source contributing pollution into the atmosphere. So what are the expected short-term effects of this increase in pollution? So there's very strong data to suggest even short-term exposure to increased amounts of pollution contribute to respiratory symptoms, increased medication use, increased emergency visits and hospitalizations, and even increased asthma mortality. But how will this also affect the incidence of new asthma diagnoses? So there's very strong data that particulate matter is associated with increasing the risk of developing asthma when kids are exposed in early life. So children are particularly susceptible. And when they're exposed during these critical windows in lung development, they can be affected by it in the sense of altering the growth of their lungs and causing airway remodeling that may be irreversible. And so it's been shown that early life exposure to traffic-related air pollution was associated with lower lung function in later childhood. And there's a distance-dependent relationship between how close you live to a major roadway and what your risk of asthma is. So this is really setting us up for seeing a further increase in the incidence of new asthma diagnoses. So these are projected changes in annual childhood asthma diagnoses due to climate change effects on particulate matter under two different scenarios. The figure to the left is under the scenario of 2 degrees Celsius increase in global temperature, and the figure on the right is for 4 degrees Celsius. And when you look within this group at particularly socially vulnerable groups, especially racial and ethnic minorities, you can see that Black and African American children really bear a much higher proportion of the risk associated with this climate change-driven pollution. Okay, and now let's talk about respiratory infection. Oh, we have a question.
Have another poll. Remember, it's interactive, right? Want to make sure we're staying awake. What percentage of asthma exacerbations in adults are caused by respiratory viruses? Take just a minute to go ahead and put in your answer. Those of you in the room using your devices, those of you also online, make sure that you're joining in as well.
Okay, I'll go ahead and read off the answers. 50% or 50% is what 37% of all of us said. 60% is what 29% of all of us said, and 40% is what 21% of all of us said, and 30% is 13% of what we all said.
So I would accept B, C, or D because it depends on where,
Trick
it depends
question.
on the source. Like, from what I've read, 40% is sort of like the minimum. It's probably higher than that. It's just, it's kind of hard to measure that sort of thing. So I would accept B, C, or D. Okay, so let's talk about respiratory viruses and asthma. So respiratory viruses are responsible for at least 40% of asthma exacerbations in adults and 90% of exacerbations in children. Viral respiratory infection in early life is also associated with increased risk of developing asthma, and this is particularly true for rhinovirus and RSV infection in early life. Okay, so what do respiratory viruses have to do with climate? So again, acute respiratory viral infections are super common, and lower respiratory tract infection is the #1 cause of death in young children worldwide. But viruses are climate sensitive, meaning they're influenced by temperature, humidity, and precipitation. And to add insult to injury, air pollution increases susceptibility to viral infections. So with regards to temperature, typically we will see these surges in certain respiratory viruses during the colder months of the year, like influenza and RSV. But during warmer winters, sometimes those patterns shift, and we might see that surge happening later in the year than we normally would. Humidity, so higher humidity has been associated with reduced seasonal transmission, which sounds like a good thing. But what the concern is that instead of seeing these like sharp peaks once or twice a year, it's going to be spread out over the whole year. And so you're going to get more continuous exposure to these viruses. Precipitation has also been linked with more severe epidemics of some of these viral infections. And there are probably multiple reasons for that, but one of which is probably more time spent indoors. Respiratory viruses are also impacted by extreme climate events, such as flooding. So flooding events were associated with a higher admission rate for lower respiratory tract infection in children, and similarly, higher rates of ED visits for influenza in children. And extreme heat as well. So in some of the recent California heat waves, ED visits for acute respiratory infection increased in preschool-age children, even after controlling for air pollution levels. And the reasons for these are probably multifactorial, one of which is they're spending more time indoors, where you're getting sort of exposure to more viruses in an indoor environment. So how does air pollution increase susceptibility to viruses? So it turns out that pollutants actually act synergistically with the virus to increase the severity of airway inflammation. They amplify allergic airway inflammation. They can alter the epithelial barrier function in the airway, modify viral entry into the cells, and impair the immune response to the virus. Most of this has been observed in preclinical models. But in epidemiologic studies, they've linked air pollution to the following respiratory viral infection outcomes: increased frequency of bronchitis, pneumonia, RSV bronchiolitis. They've seen increased rates of influenza in the elderly, and then increased risk of lower respiratory tract infection in children with asthma. So there's definitely something there. And there's also been some suggestion that pollution might increase susceptibility to the SARS-CoV-2 virus and might be associated with higher COVID-19 related mortality. And so this is a figure from a paper that came out during the very early days of the COVID pandemic. And you can see what they're measuring here is tropospheric nitrogen dioxide levels, which is another type of air pollutant. And so this area in red, indicating the highest levels of pollution, it corresponds to the Lombardy region of Italy that was so hard hit by COVID in the early days. So what does this mean for asthma? So in terms of the effects on established asthma, we're going to see altered seasonal patterns of viral-induced asthma exacerbations. And potentially, because of pollution, increased susceptibility to these infections in the first place. And in terms of asthma incidence, or the development of new cases of asthma, this more persistent exposure to virus throughout the year sets us up for more risk of early life infections and may impact the risk of developing asthma. So we may see, yet another reason why we may see more new asthma cases popping up. And just at the end here, I just wanted to make sure to mention that these hazards are not equally distributed across the population. So some groups are more vulnerable to these climate-induced changes. And a lot of this is due to the legacy of discriminatory practices like redlining and residential segregation that resulted in intentionally putting polluting facilities in low-income communities and communities with high percentages of racial and ethnic minorities. These communities are often also placed closer to major roadways. And so there's already disproportionate exposure to pollution. So these groups are even more vulnerable to the changes that we're going to see because of climate change. And these populations are also more vulnerable to extreme climate events. So communities of color are disproportionately affected by extreme heat events, likely because of the enhanced urban heat island effect, where these communities have less green space, they have more greater density of buildings that are absorbing and emitting heat. And these communities are also more likely to live in low-lying flood-prone areas and have fewer resources to adapt, evacuate, and rebuild. And unfortunately, these populations are also the ones that see the largest spikes in morbidity and mortality following extreme weather events. So in summary, climate change influences 3 of the most common drivers of asthma morbidity: allergen, air pollution, and respiratory virus. The impact of outdoor allergens like pollen is expected to increase as pollen seasons lengthen in duration and intensity. Climate change and air pollution are very tightly linked, and ozone and particulate matter exposure are expected to increase due to climate change. Viral respiratory infection patterns are influenced by climate and by extreme weather events, and air pollution increases susceptibility to respiratory viral infection and may induce more severe illness. And some groups are definitely more vulnerable to these consequences of climate change than others. So that's important to remember as we're coming up with adaptations that we need to apply to the most vulnerable communities first. And that is it.
Thank you, Dr. Burbank. Awesome. So we have time for a couple of questions. Let's start with online first, and then we'll take one in the room.
Sure. Melinda from the chat says, as a school nurse, I am seeing an increase of pneumonia and upper respiratory infections. Do you feel this is related to the environment?
I mean, I think it definitely could. I think COVID-19 sort of threw a monkey wrench in everything. It really flipped our viral infection patterns on its head. And so whereas we might normally see that spike in infections, both lower respiratory viral and pneumonia, we might normally see those only in the colder months. Right now, we're seeing them spread out across the year. And so I think COVID-19 is still having ripple effects.
Thank you.
Yes, good morning. My name is Rosa Garcia. You mentioned about the carbon dioxide going high. It will be part of the pollution for as a trigger for asthma. Our non-profit organizations that I work for, we recently came up with one topic. Then we got concerned about it, and that's why I bring it over here. Not only from you, but for other colleagues here, if you have any information or is being addressed about it, which is the problem with the inhalers that for asthma or COPD use chemicals that actually harm the environment. And then now we're looking into using the soft medications for it, but we find out that the soft medications is mostly for COPD, not for asthma. And the hydrofluorocarbon, HFC, on the propellants from the inhalers are the potent greenhouse gases that trap heat in the atmosphere, even thousands more times of the regular carbon dioxide. So we would like to hear if this is kind of like totally a new topic that it need to be discussed, or it's already on, on agenda for future. But that's our major concern. They're looking into instead using the HFA inhalers, going to the powder ones, but the powders are not actually like the mommy was sharing with us, is they're not that cheap. So it is
They're
like
also not great for
$500
kids.
every inhaler monthly. So is anything that you address in regards of the pollution that you mentioned to us, or what it could be possibilities to help for that pollution that we actually doing increasing when we're using those HFA inhalers?
Yeah, this is a hot topic, but it is a new hot topic. So, I expect there to be more sessions about this, both at the college meeting and the Quad AI meeting this year. But yes, so this is a big topic of conversation. So the propellants used in MDIs, they are called, as a group, they're called F gases, or fluorinated gases. And they are greenhouse gases. And while they only make up a small sliver of the greenhouse gases that we produce, those gases are extremely potent, like 300 times more potent than carbon dioxide. And so I've had people say, well, I mean, really, is that a concern, or should we just be focused on cars and, industry putting out all these greenhouse gases? But I think the fact that they are so potent, that is a concern. And I think really in Europe, they've sort of latched onto this idea a lot earlier, like a lot of other things. And so they've been shifting away from MDIs for years towards the dry powder. And I think it's important to think about shifting that when we can, But you're right, cost is a huge issue because we're all at the mercy of the payers and what they're going to cover. And also the dry powder inhalers or the soft mist things, they're not great for kids. So kids have a lot of trouble coordinating and then creating enough inspiratory force that's needed to really deliver that drug where it needs to go. And I'm a pediatric allergist, so like for me, I'm pretty passionate about still having MDIs be available. But yeah, I mean, I think as a specialty, we probably are going to have to shift people that we can more towards those environmentally friendly products, but only when it makes sense in terms of cost and delivery.
Thank you, Dr. Burbank. That was a great question. Lots of unintended consequences in our environment and our medications, but thank you for laying that out so wonderfully for us. Thank you. And I know that there are plenty of questions that we can't always get to for each presentation. Feel free to write them down. Feel free to put them in the chat so that we can follow up.